Hi everyone, I hope that you're well. A few people said they got a bit confused with the rationalising the denominator question, which is to do with surds, which is a real confusing topic anyway. So I thought I'd do a real quick recap of surds and what they are exactly, and then give some examples of rationalising the denominator. Okay, so the first thing we'll say is, what is a surd? Well, a surd is a type of a rational number. Yeah, a surd is a type of a rational number. Well, that's no use to me unless I know what a rational number is. Well, a rational number is anything that can be expressed as a fraction. A rational number is anything that can be expressed as a fraction. So 7 can be expressed as a fraction, for instance, because that would be the same as 7 over 1 or 14 over 2 or whatever. This is a type of rational number. 2/3 would be a type of rational number because it is already a fraction. If we think about it, any decimal let me just rephrase that. A terminating decimal, i.e. one that comes to an end, so 0.8, that's a type of rational number because that can be expressed as 8 over 10 or 4/5 in its simplest form. Therefore, that's a rational number. It can be expressed as as a fraction. And if we remember, covered this topic just before lockdown, any recurring decimal can be expressed as a fraction. Therefore, any recurring decimal must be a rational number. Any recurring decimal must be a rational number. So what's an irrational number? Well, if a rational number can be expressed as a fraction, then an irrational number, let's write those two things down. A rational number can be expressed as a fraction. Therefore, an irrational number cannot be expressed as a fraction. So what could we think of as some irrational numbers? So one that people often come to is pi. Pi would be an irrational number that can't be expressed as a fraction because it goes on forever without any repeating decimals. There's no recurrence in its decimal. But the more kind of ones that come to mind are things like this. The square root of 3, for instance. That's an irrational number, and in fact that's a type of surd. Yeah, that's a type of surd. Because if I put that into my calculator, it will produce a decimal with no recurring elements to it, therefore it can't be expressed as a fraction. It doesn't just mean, by the way, guys, that anything with a square root sign over the top is therefore a surd. Because if I said the square root of 25, because that's a square number, it has a solution. Assuming we're talking about the positive solution, it will just be 5. Therefore, this is not a surd. This is not a surd. But this is. And other things like whatever. Let's think of another one. Square root of 5 or square root of 21. Yeah? So anything. There's something we can do where we can simplify it, surds. I'll probably come to that another time. So let's look at what this says. Fact. Let's have a look at rationalising the denominator. So if I rationalise the denominator, well, what does that mean? So currently, let's take an example. If I had 1 over the square root of 3, rationalise the denominator. I want to make the denominator a rational number. Yeah, we talked about how the square root of 3 is not a rational number. So how could I go about doing that? Well, if I multiply square root 3 times square root 3, square root 3 times square root 3 will give me square root 9, which is the equivalent of 3. Yeah? So that would work it out. But I don't want to mess up the structure of the number. I want this to be equivalent. If I put in this into my calculator, the thing that I'm going to come up with in a second will be equivalent to 1 over the square root of 3. Well, if I multiply by square root 3 over square root 3, that's the same as multiplying it by 1. So anything multiplied by 1, if I think about it, will result in the same number. I'm not changing the structure of the number, I'm just expressing it a different way. 1 times square root 3 is square root 3. Square root 3 times square root 3 is square root 9, or just 3. Here, this is me, and I've rationalized the denominator because no longer is my denominator an irrational number. Just to be clear, guys, this is exactly the same as this. You can try that by putting it in your calculator. The only difference is that this has an irrational denominator, and in this one I've rationalized the denominator. I don't care that the numerator is irrational. All I'm caring about is rationalizing the denominator. Let's go for another one. So if I had square root 7 over square root, if I had 1 over square root 7, then, well, I'm thinking if I multiply that by square root 7, that will rationalize the denominator, but that will change the structure of the number. If I make it square root 7 over square root 7, that is equivalent to 1. 1 times square root 7 is square root 7. Square root 7 times square root 7 is the same as 7. I have rationalized the denominator. To be clear, 1 over square root 7 is equivalent to square root 7 over 7. Mean exactly the same thing. So that's how we go about doing it. We might get questions like this though. So if I have 21 over square root 7, thinking to myself, how do I make that denominator rational? Well, I'm going to multiply it by square root 7. I want to make this equivalent to 1, so I'm going to make that square root 7 as well. Or 21 times square root 7 will be 21 root 7. And root 7 times root 7 is 7. We'll notice though, this is slightly different. This time I can simplify my fraction because here I have 21 over 7 is being multiplied by square root 7. Well, 21 over 7, 21 divided by 7 is the same as 3. This will be the same as 3 root 7. So we'll come on to our last one. This was the question. If I have 12 over root 6, well, I'll times that by root 6 over root 6. That will give me 12 root 6 over square root 6 times square root 6 is 6. That will be my first mark, but 12 divided by 6 is 2. This will be my second mark. Okay, remember 12 over 6 is the same as 2. If I simplify it, give your answer in its simplest form. Otherwise, this would have been okay, but this is it in its simplest form. Hopefully that makes sense, guys. Speak to you soon. Bye.